Hi everyone and welcome back to That's Engineering. So in this series of videos, we're going to look at how to conduct a biomedical experiment and analysis. We're going to start from the very basics, that's setting up your experiment, recruiting your subjects, running the experiment, collecting your data, and then drawing inferences and conclusions, and of course analyzing your data as well. So this series of videos is mainly targeted for someone who is kind of new to the biomedical engineering or biomechanical sciences field, and for someone who is still starting off with performing research in this relevant area. So the first video, that's this one, part one, we're going to look at the general flow or the overall stages you would go through when running this sort of research experiment. And in the subsequent videos, we will single out each stage, dive deeper into it, and look at the finer points of how to actually conduct these experiments and collect your data. So if you guys like this video, don't forget to give me a thumbs up. And as always, please subscribe. Alright, so now let's look at the general flow when conducting a biomedical experiment. The first is, of course, the conception of the study. So it's at this point that you'll be doing a lot of planning and desk research. You'd need to come up with an aim. What is it that I'm actually trying to do? You would need a hypothesis, a problem statement, perhaps even a research question, and you would need tons of literature. So in essence, you would need a literature review. And this is actually going to help you find the gaps, what has already been done, what hasn't been done, and what's the gap in the work. You would also need to plan things out like what sort of variables am I looking at, what sort of data am I going to collect? Is it going to be optical motion capture data or surface electromyography data from muscles, acceleration data from IMUs, things like that. And what sort of equipment am I going to use? Do I have the necessary sensors, the necessary equipment to collect these variables or these data? You would also need to think about your subjects. How many subjects am I going to collect data from? What are my demographics? Are they going to be predominantly Asian or European? Are they going to be young, middle-aged, or older adults? Are they going to be male or female, or a mix of both? Things like that in general. But if I can emphasize on two things, it's the aim and the contribution of your work. You really need to establish your aim. What is it that I'm trying to do? What is it that I'm trying to solve? And that should lead you to a rough idea of your contributions at the end of the experiment. What am I contributing to the field? What am I gaining? Or what is the result of this study? Keeping in mind that both your aims and your contributions do tend to change as you actually progress through the experiment and collect your data and analyze your results. So the next step is going to be obtaining ethical approval. Now, if you're in a university or an organization, you most likely have some sort of ethical body that grants approval, and this is very important when performing experiments with human or animal subjects. So you really need to get ethical approval before collecting or running your experiments. Then comes subject recruitment. That's advertising your study, calling participants, asking people to join and take part in the experiment. And then, of course, the data collection. So this is where you fix all the sensors, hook the subject up to all the equipment, whatever it is, run the experiment, collect the data. And something that's quite often overlooked but very, very important is data storage and labeling. I can't tell you how many times I've lost data due to mishandling or mislabeling of data in general. So it's very important to maintain a consistent pattern of labeling data and, of course, backing up your data and storing it properly. You would then need to process the data, pre-processing, something like maybe filtering, removing noise, motion artifacts, and then you can jump into the biomechanical analysis. So there are a bunch of softwares that people use. The two that I personally use are Visual 3D and OpenSim. Or you can even use software like MATLAB or Python to run the analysis. And then you would actually get your results, which you would need to tabulate and organize neatly. And from these results, you can run a statistical analysis. And it is the inferences or the conclusions from this analysis that would tie back up to your objectives and your hypothesis of the study. And this is, in general, the stages you would run through when performing a biomedical or a biomechanical experiment. All right. So in this video, we'll cover two stages, the first being ethical approval and the second being subject recruitment. So ethical approval stems from the Declaration of Helsinki, which was put forward by the WMA, the World Medical Association, in 1964. You can go ahead online and read through it. They have a bunch of clauses, but in essence, it ensures that you, as the experimenter, always considers the health, well-being, and safety of your subjects or your patients first, before you look at achieving the goals of your experiment. Now, ethical approval is usually granted by a body that's part of your university or your organization. Each of these bodies have slightly different procedures, but you will need to apply for ethics if you have human or animal subjects, and you will need to get ethical approval before you actually start your data collection experiment. The process or the procedures when applying for this vary from university to university, so you would have to look up your relevant university and your relevant body and find out what their procedures are and how to apply for ethical approval. But two things that you would most likely need are an explanatory statement and a consent form. So let me show you an example of that. All right. So this is an example of an explanatory statement that I used in one of my projects. And its purpose is basically to explain to the subject what would be required of them during the experiment. What do they have to do and why are they doing what they are doing? So on top over here, you would have your university or company logo. You need to have a project ID and a title. That's usually allocated to you by the ethical approval body. You'd have to have all the names and contact details of the researchers, of the experimenters in your team. And you'd have to provide information with respect to things like what does this research involve? And you'd have to mention the procedure prior to the experiment. That means what the subject needs to do before they come to the lab on that day. The procedure during the experiment, so what the subject needs to do in the lab on that day, step by step. And then, of course, the procedure after the experiment, what is expected of the subject once the experiment is done. Are they supposed to come back for a follow-up, something like that? You need to talk about funding and why they were invited for this research. Did you target specific demographics? Did you target them specifically for a certain reason? Things like that. And of course, you would have to talk about consenting to participate in a research. A subject can technically withdraw their consent to participate at any point during the experiment if they feel uncomfortable. And you should allow them to do this so that you don't compromise their safety and their well-being. You need to go through the possible benefits of performing the research as well as the risks and how you would mitigate those risks and ensure their safety. And of course, it's normal to offer some form of compensation or payment, maybe in the form of gift vouchers for subjects who come to the experiment. Confidentiality is very important because you'll be collecting biometric or biomechanical data from subjects. And you also have to inform them of how you would store this data, how you would store it confidentially and not let the data be lost or leaked. You can talk about the results, how you would handle the results of your study, whether you will share it with the subjects, whether you're going to publish it, whether you're going to put it into a database, something like that. And you have to leave a room for complaints or someone that the subject can reach out to if they're not happy with how things are done. So this is usually the head of the lab or a manager or someone from the ethical body itself. And that's practically how an explanatory form should look like, an explanatory statement should look like for a study. And with this, you would also need to provide subjects a consent form. And the consent form again should contain the same project ID, title, and the name designation of the chief investigator. And you should have a list of things that the subjects need to consent to. So I've just given two examples. For example, in my study, I put motion capture markers on a subject. So I had to get them to consent to me touching them and placing those markers and then recording them moving and performing motion. So I had to get their consent for that as well. And that's what the consent form is for. You need the name of the participant, the signature, and of course the date. Usually the consent form is given to the subject on the day of the experiment as they arrive. And you should always file this and keep it carefully as it is the consent given by the subject to take part in the experiment. Right, and the final stage we'll look at in this video is subject recruitment. So you can recruit your subjects in any way, that's up to you. But these are a few general tips that I think may be useful. The first is to randomly select your subjects. Do not cherry pick your subjects, as this can introduce bias. So it's always a good idea to put forward an advertisement or a flyer and randomly let your subjects enroll or volunteer for the experiment rather than cherry picking them, because this can influence a lot of bias into your data and your results. The second is to use similar sample sizes or keep equal sample sizes between subject demographics, for example, biologically male and female, because there can be significant variations between these two groups. Also, it's useful to recruit subjects across age groups, young, middle-aged, and older adults, but again, it depends on the experiment you are performing. Something I tell my students quite often is to ensure their sample sizes are above 30. So this ensures a normal distribution and keeps sufficient statistical power when you're running your stats analysis according to the central limit theorem. But in practical sense, it's not always possible to get such a large number. Pilot studies or smaller studies target from 10 to 20 subjects. But if you have enough resources, I suggest you go for at least 30 subjects. And something that a lot of people miss out is compensating their subjects. The subjects are volunteering, so it's quite a normal thing. It's quite a nice thing to compensate them for their time. Payment in the form of cash or money may not be very professional, so gift vouchers are usually the way forward. And this is a template of an advertisement I made. I assume you guys can probably do a much better job than I did on Canva or PowerPoint, but this is just a basic template to start from. Mention your project ID, have a call so that you are calling for volunteers to take part in your experiment, the title of your experiment, and then a little bit about your experiment. It's important in your advertisement or flyer to keep your technical language to a minimum so that a normal everyday person who's not in the field can read it and understand what it's about. You need to specify your inclusion and exclusion criteria so that you get the specific subjects from the specific groups that you're interested in, or with specific characteristics that you're targeting, and of course give some contact details and a location and where the experiment will be held. It's always nice to add the potential benefits to society, so subjects can relate to it and they feel interested in taking part and volunteering for the experiment, and of course give some contact information at the end. You can also put a link to the explanatory statement to maybe a few videos of a trial experiment and how it would look like, so people know if they're actually up for it or if they're not really interested. Alright guys, so that's the end for part 1 of this video. In the next video, we'll look at data collection, the finer points of how to actually run a motion capture experiment and collect the data you need, and perhaps we'll touch on data storage and labeling. If you guys like the video, don't forget to leave me a thumbs up. Don't forget to subscribe. Thanks for watching, and I'll see you guys in the next video.